Hello, this is Kumar Mitra, CSC578. This is my final project for spring 2019. I am going to go through the Jupyter Notebook first and attempt to run each step here. The first thing I did was load and install Keras into Cognitive Labs GPU version of the Power AI, and I ran it ahead of time because it does take some time to run that. Let's go ahead and import the packages needed. So our standard NumPy pandas, all the Keras and sklearn, matplotlib for some plotting. We will go ahead and load the data sets. So we have the training data frame and the test data frame. So that would be your respectively the climate hour train and the climate x-test CSV. Then we do some print of the shapes just to cross-check that these are the correct columns and rows we're expecting. Oh, I did not load testdf. So if I run it now, it should be just fine. There it is. And train df, describing it, just to get a feel for the basic statistics here. Same goes for the describe for the test. Now we need to drop the date time from the train data set. So let's go ahead and do that. Notice how now we have 14 columns instead of 15. We're creating the time window here. I'll run through it. Normalizing, so this is where the normalization process takes place for the train and test data sets. I use the min-max scaler from sklearn. Targets for training data set. Again, the Y trains. So I'll run through it all, each step. Okay, train data set for the training parts, X-train and the X-test. So looking at the shapes and such as well. And now we go to the part where we reshape the train to be 3D, and we do the same with the X-test as well, X-train and X-test. So let's go ahead and do that. Notice the shapes over here, and printing out the shapes over here. And now we step into the building the model. So let's go ahead. This is my final best model that I came up with. It's all described in my documentation as well. I ended up using sigmoid for the activation. Used 54 neurons, and obviously loss being the MAE and the optimizer atom. Dropout was 0.5, and there's some of the other layers I used here. So let's go ahead on that model and print out the summary. Notice how there's 34,393 total trainable parameters. Non-trainables is at 0. That's great. And now we fit the model. So I will start it. I use 64 batch size epochs of 30. So I will start it. However, it does take a long time to run. So I am going to skip the rest of it and open up my existing version of the notebook that I saved as HTML, and I will go through where we stopped for the model building. So here's basically everything that's currently running on the other screen here, and notice how loss is 0.01. That's after 30 epochs. That was the best one. Plotting the history of the train data. and then doing the predictions of the excess and scaling it back because we normalized it before, so now we are rescaling that, and then we save it to Kaggle. And those were uploaded to Kaggle, and my score was updated with this one after the submission has ended. But my score did improve with this model. All right, thank you so much.